Hey there, students. Here's a video to show how to do a comparison between two populations' proportions using StatCrunch. So I'm looking at problem number 5 from our homework number 12 on chapter 9. And specifically, we can see this is a problem that would show up from section 1 of chapter 9. It says, test the given claim, identify the null hypothesis, alternative hypothesis, test statistic, p-value, then state the conclusion about the null hypothesis as well as the final anyway, they ask us a bunch of stuff. And then it gives us a summary of their sample results. Among 2,006 passenger cars in a particular region, 225 had only rear license plates. Among 323 commercial trucks, 45 had only rear license plates. So their two populations are commercial cars or passenger cars and commercial trucks. So commercial trucks and passenger cars are the two populations. It says a reasonable hypothesis is that commercial trucks owners violate laws requiring front license plates at a higher rate with a greater proportion, meaning than owners of passenger cars. Use a 0.01 significance level to test that hypothesis. So in part A, it says test the claim using hypothesis test, and the first part of that is to set up our null and alternative hypotheses. All right, so it says identify the null alternative hypotheses, and it says let population 1 correspond to the passenger cars and 2 be the commercial trucks. And let success be a vehicle that only has a rear license plate. And they told us, for example, among passenger cars, 2,006 passenger cars, 225 had only a rear license plate, so that's a success. All right, so the claim for the reasonable hypothesis that we're testing is that commercial trucks, that would be the population 2, has a higher proportion of successes, meaning only one plate. So they've set these up with the population 1 compared to population 2. So if population 2 has a higher rate violating the law, being a success, that means that P1 is less than P2 is our claim. And so that would mean our null hypothesis is that P1 is equal to P2, and that our alternative hypothesis is that P1 is less than P2. So we see that in B for the way they've set up their options there. So now we're supposed to identify the test statistics. So we're going to use StatCrunch to get T-stat and, the test statistic and the p-value. So I'm going to go to StatCrunch, who I have open here, and under Stat, this is going to be a proportions stats. And in the past, we've done one sample, but now in Chapter 9, we're looking at 2 samples. And again, they didn't give us the data, they gave us a summary. So that's proportion stats, 2 sample with summary. So they want the successes and observations from each of the samples. So we have to remember here, sample 1 for P1 is the passenger cars, and that was 225 out of 2006. And for sample 2, which was the commercial trucks, we had 45 out of 323. So I'm going to try to double check as they enter these in. Keep in mind, if you are just doing a homework like we are here, the problems are repeatable. If you make a mistake, you can come back and fix it. But I would suggest that you practice trying to get in the habit of being very careful about the details when you enter them in, especially on these calculator problems, because on a quiz or a midterm or something like that, you're not going to find out that you made a typo or that you made a mistake until you got the problem wrong. And at that point, you'd have to redo the assignment on a quiz to get a better score, or on a midterm, you're not going to get another shot at it. So it's good to, while the problems are repeatable in the homework, practice and prepare about trying to be as close to error-free as you can. Everyone makes mistakes, but trying to double check your entries so that you have a high rate of success and a lower rate of just making careless errors by typos and things like that. So I have 225 out of 2006, and I have 45 out of 323, so that looks right. Now our hypothesis test, in StatCrunch they frame that in terms of the difference between P1 and P2. So if our null hypothesis is that they're equal, well, that means that their difference is equal to 0. And that our alternative hypothesis is that P1 is less than P2, so that would mean P1 minus P2 would be less than 0. So then I can compute, and then it's going to give me what I need. So for example, the test statistic for a proportion would be a z-stat, and that's here, and I want that to 2 decimals. So I'm going to copy the first 2 decimals, and I see I do not need to round up. Then after that, they want the p-value, and I'm going to do that to 3 decimals. So looking to 3 decimals here, I see I do need to round up the 8 on the end. I need to round up to a 9 because it's followed by 6. All right, and so then they want us to draw a conclusion. So again, how do we draw a conclusion? Basic thing to remember, if the p is low, the null must go. So our p-value was over 7%, and our confidence significance level is only 1%, so the p is not low. So in this case, we're unable to reject the null because the p is not low enough. So we failed to reject the null. That looks like B and D here. And when you're failing to reject the null, that's because there was not sufficient evidence to do so. So that's going to be D in our choices here. And so now they want us to also perform the hypothesis test using the confidence interval approach. And so this will be a little bit more prevalent in Chapter 9. It was introduced in Chapter 8, but we didn't have really problems that focused on that. So now we have to re-examine this idea. So it says, identify the confidence interval limits for the appropriate confidence interval. Let population 1 still correspond to passenger cars, and 2 being the commercial trucks. Let a success be a vehicle that has only rear license plates. So none of that has changed. So what I'd like to point out is that to do this, they're asking for the confidence interval, for the appropriate confidence interval. So we have to figure out what that is. But we've already entered in all the summary stats. So instead of me closing this and entering those again, I'm going to go to Options, and I'm going to Edit. Then I don't have to re-enter that summary statistics information. Instead, I'm just going to switch from the hypothesis test, where they give us the test statistic, and go over to the confidence interval. So then all we have to do on the confidence interval, as we did in Chapter 7, is enter the confidence level. But they're not telling us what that is. They're telling us to do the appropriate confidence level. So we have to figure out what that means. So the confidence level to be appropriate will be based on our the confidence the significance level of 0.01 that the problem gave us. So for a significance level of 0.01, we have to say, is this a two-tailed test or a right or left-tailed test? And so this is a claim in which our claim is about being less than a particular value, being less than 0 for the difference, or P1 being less than P2. When you have a less than or greater than claim, that's a one-tailed test. That means the significance level of 1% needs to be the area in one tail. Remember, a confidence interval will be in the middle of the distribution, and there'll be tails on either end. So if we want one tail to be 1% area, that means by symmetry, the other tail will also be 1% area. And if each tail has 1% in it, that means the interval in the middle has the other 98%. So to perform a confidence interval of the appropriate level for a 1% significance level on a one-tailed test, then both tails each have 1%, so we need a 98% confidence interval. confidence level. So I'm going to put 98% for the confidence level of our confidence interval. That will make each of the tails have 1%, so the tail that we want will have 1% in it for the 1% significance level. A little bit of confusion there, but that's how that works. So now I've made the confidence interval, and I would do this to 4 decimal places. So looking at the left value, looks like the last digit is an 8 that I need to round up to a 9. So I'm going to copy that over, put that up to a 9. I think I copied that correctly. I'm pretending this is a midterm. 4 decimals ends in a 5 that needs to be rounded up to a 6. So let's copy that over and round that up to a 6, and it should be good. All right, so now we want to use this confidence interval to draw our conclusion. And again, the idea here is that we're 98% sure that the actual difference in the population proportions for the whole populations would be in this range. Well, since this range goes from a negative number to a positive number, in the middle of that range somewhere is a 0. Within that range is a 0. So that means it's quite likely, and our confidence interval would suggest it's certainly possible, that there is no difference between the population proportions. And our claim is that there is a difference. And so this does not support our claim. So just like what happened with the p-value was not low enough to reject the null. Well, because our confidence interval includes a 0, we can't reject the null idea that the difference is 0. So to fill that in this conclusion here, we say because the confidence interval limits contain 0, there is not a significant difference between the two proportions. There may be none at all. There is not sufficient evidence to support the claim that commercial truck owners violate the laws at a higher rate, because there may be no difference between them at all. So there we go. So a little bit of detail to this question. Hopefully this helps. Keep up the hard work and come see me if you need help.